All right, so tomorrow we are spiraling and we're doing a second look at old concepts so we can bulk up and get strong before benchmarks and test. It looks like a lot. I know it does, but there's lots of big pictures and some of them are super quick. All right, so these are called boundaries, these numbers that they give. And it says we need to use this for 1 through 4. So before we start, what are they counting by? 20, 30? Yeah, good. They're counting by tens. And what's half of a 10? 5. So what do you think this is? Good, let's label it 25. Let's label them 35, 45, 55, 65, 75. And what would be right here in between? If that's 20, that's, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, and so on. And if y'all do not remember when we round, if this is about your neighbors, rounding deals with the neighbors, and I'd make them write this, rounding with neighbors. This is my digit. If my neighbor is 5 or more, I pump up that score. So I'd pump that number up. But if my neighbor is 4 or less, I let it rest, as in this digit stays the same. So I want y'all to, girls, read the question. All right, what are we looking for? We're looking for a group of numbers closer to 30. So which ones are closer to 30? Well, look right here. If you're 5 or more, you'll pump up the score. You'll pump up to that next 10. So that means you have to be 25, 26, 27, 28, or 29, which goes with our saying. If you look at the neighbors, 5, 6, 7, 8, 9, if your neighbor is 5 or more, you'd pump up the score. You'd pump up 20 to 30, because these are closer to 30. So not a 24. 24, a neighbor of 4 or less would let it rest. No. Right here, I'm looking at the 2, thinking closer to 20 or closer to 30. I'm looking at the 2 as in 20 or 30. Well, if my neighbors are 5 or more, we pump up the score. 26, 28, 29 are all closer to 30. So you can use your number line or you can use your knowledge of 5 or more. All right. Number 2, boys, read it to us. All right, what should we summarize? We're looking for all numbers round 70 except, these are the hard ones. So this is when my puppy dog years, I become on full alert. Like, what? Oh, they're trying to trick me because we want the one that is wrong. So we're looking for 70. Right now, this is in the 60s. So it's either closer to 60 or 70. 60 or 70. This one is either closer to 70 or 80. It's in the 70s, so I either stay 70 or I pump up to 80. Well, who do we look at for rounding help? Yeah, the neighbor. So let's circle the neighbor and say the saying. A neighbor of 4 or less, yep, you let it rest at 60. A neighbor of 5 or more, you pump up the score, so that one would become a 70. A neighbor of 4 or less, I let it rest, so this one would be 70. A neighbor of 4 or less lets it rest, so this one would be 70. All of these will be 70 except F. This is the one that will not move to 70. Okay? I want the whole class read this one. All right, what are we looking for? We're looking for a number that does not round to higher boundary. Well, I may not understand boundary, but higher, I want the number that does not pump up the score. I do not want to pump up higher. 16. Well, 16 starts with a 1. That means you're at a 10, or you might pump up to 20. Who do I look at? The neighbor. 5 or more, what would we do? Yeah, we'd pump up the score. So this one would move up. That makes it higher. I do not want to go higher. 85. 85 is between 80 and 90. Who do I look at? The neighbor. What saying belongs with this neighbor? Yep, 5 or more. You'd pump up the score. You'd pump up 80 to 90. I don't want to go higher. 48 and 63. Which one do y'all think would not pump up higher? How do you know it's D? Very good. A neighbor of 4 or less lets it rest. You would rest at 60. All right. I want y'all to look at this next one by yourselves. And tell me, what should we summarize? What are we looking for? Well, I don't know that I'd make them do this one on their own. So basically, this one doesn't have a question. We just need, she places this star to locate 47. So what do we know about 47? It's between 30 and 40, closer to 40. Well, 47, if you're 47, you're after 40, and you're headed to 50, and you could then show them over here, like 41, 42, 43, 44, 45, 46, 47, 48, 49. 47 is between which two tens? Yeah, we're between 40 and 50. Which one are you closer to? Yeah, 50, which makes sense. A neighbor of 5 or more pumps up the score. So I should be between 40 and 50, and I'm not equally close. I'm closer to 50. We just saw that on the number line. All right, look at your 3Ds. We're studying the pyramid. How do we know that's a pyramid? Right, it comes up to 1 point and it has 1 base. How do we know that this is a prism? Yeah, it has 2 bases and rectangular faces. We want a true comparison. So girls, read us A. It says the prism has the same number of faces as a pyramid. Faces are the flats, so you've got 1, you've got that side 2, you've got the back 3, and this one 4, and the very bottom, this has 5 faces. Let's see. Side and side, that's 2. Top and bottom, that's 2 more, and then side and side. So we've got 2, 4, 6F. Do they have the same? No. Boys, read us G. Okay, it says the prism has 3 more vertices than the pyramid. Prism. Where are the vertices? Yeah, the points. Let's count. 1. Let's prove it as we count. 2, 3, 4, 5, 6, 7, 8 vertices. All right, let's go find the vertices on the pyramid. 1, 2, 3, 4, 5. 5 vertices. Is 8 3 more than 5? Well, let's see. How much more is 8 than 5? 3. So is this true? Yes, that's your answer right there. All right. Fraction. Taylor and Ron each ate a fourth of the candy bar. What do we know? What do you call this number on the bottom? How do you know it's the denominator? Yeah, because you get down with your denominator. And what does denominator tell us? Divided into. Yeah, we're divided into 4. Divided into 4. What's this top number called? Numerator. How do we remember that? Yeah, because we gnawed the numerator. And what does in numerator say? Know what you're looking for. So we're talking about eating 1 each. This is Taylor's. This is Ron's. Well, I want you to scan the question. All right, what are we looking for? A statement not true. You better put on those puppy dog hearing. You got to be at full attention, because not true means that 3 of these are true. These are hard because we're trained to circle truth. It says Ron's is smaller than Taylor's. Let's first just look. Is Ron's piece smaller than Taylor's? That's true. And they say it's because Ron's candy is smaller. All of this is true, so this is the right answer. And if they went yes, then they all died and went off the cliff. If it's not true, is that true? It is true, but I'm looking for the one not true. Taylor and Ron both eat the same amount of candy because they both eat 1/4. Do Taylor and Ron eat the same amount of candy? I hear yeses and nos. Let's think about that. Both boys eat a part of a candy bar that represents a unit fraction. Are both of these unit fractions? How do we know? Yes, because a unit fraction has a numerator of 1. So, yes, this is true, which makes it wrong. Taylor eats more candy than Ron because his candy bar is larger. Is Taylor's larger than Ron's? Yes, so this is true. Why is this one not true? Because it says they both eat the same amount, and it told us that both ate 1/4. Yes, because are the candy bars the same? So this is a bad fraction right here. This is not true because I can't compare 1/4 to 1/4 when they did not use congruent pieces, same size, same shape. So that covers quite a few of your fraction concepts right there, depending on how you review it. All right, girls, read us about Mia, Mandy, and Molly. All right. What's our question? We want the fraction each girl receives. Well, how many girls are there? 3, yeah. Let's draw Mia, Mandy, Molly. I'll even give them legs today. How many pieces of pizza are we talking about? 6 pieces. 1, 2, 3, 4, 5, 6. 6 pieces. So you get a piece, you get a piece, you get a piece. How many pieces is that? 3. Can they have more? So I've used 1, 2, 3. 1, 2, 3. Now I've used up this piece. So each girl, and it wants a fraction, each girl is receiving 2 out of how many, y'all? Nope, not 2/3. Yeah, there are 3, but oh, that would be right. Sorry. 2/3. They would probably have said, sorry, 2/6. That was backwards. Because we look at one set, D divided into 3, D divided into 3. Each person is getting 2/3 of the pizza. All right? There are 31 plants in the garden. Blah, 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 blah. All right, what do we want to summarize? What are we supposed to do? We're supposed to draw a picture, show Micah's garden odd number plants. All right, so how would we do this? Well, even and odd. The big thing is that even numbers can be divided into 2, odd numbers cannot. So I'm going to use check marks because I've learned they're fast. So we're going to go 1, 2, 3, 4, okay? All right, y'all get caught up. All right, keep going. 5, 6, 7, 8. Start a new row. 9, 10, 11, 12, 13, 14, 15, 16, new row, 17, 18, 19, 20, 21, 22, 23, 24, new row, 25, 26, 27, 28, 29, 30, 31. I see 1, 2, 3, 4 groups of 4, which is how many, y'all? 16. Over here, it's 4 plus 4, that's 8. 4 more, 9, 10, 11, 12. 13, 14, 15. I've drawn a model. How do we know that this is an odd amount? Okay. So let's write this in a sentence. 31, 30-1, capitalize your sentence, divided into half, there we go, is not even or not equal or something like that with a period. And then I'd get up and go walk around to make sure that their drawings, that they have the same notes and all that. All right, so here's one thing I reinforce. Odd numbers when divided into half, hi-ya, will not be equal, even will. All right, what's our next set of directions? We're going to circle numbers not even. Not even. Well, if you're not even, you're what? Odd. And here's a big thing we need to write. Odd numbers end in zeros, ones, 3, 5, 7, 9. Why did I say 0? Odd numbers end in 1, 3, 5, 7, 9. So look at the ending. 0, nope. 7. Do odd numbers end in 7? Yes. Do they end in 9? Yes. Do they end in 2? No. Do they end in 5? Yes. Do they end in 1? Yes. All right. So it wants to know, how do I know? Well, that's one reason I know. And let's write down here, even numbers end in 0, 2, 4, 6, 8. And that way you're reviewing both odd and even. Okay, then we're going to do some vocabulary. We want same product as 3 times 8. What the heck's a product? They want the product of 3 times 8. Okay, good. The product is the answer to multiplication. So, what is 3 groups of 8? 24. So 24 is the product. We want which one of these has the same product. Now remember that when you're using multiplication numbers, your teacher says you better memorize those multiplication facts. All of these are known as facts, as in factors. And they equal, their answers are called a product, because products are the answer to multiplication. They're answers to multiplication. All right, so I see 9s. Let's do the 2 9s. Well, we should know what 2 9s are. 18, that is not the same. 3 7s. 7, 7, and 7 are 21. That's not the same. 4 6s. And we know that's 12 plus 12, which is 24. Is that the same? Yes, there it is. Down here we get another vocabulary word. We do not want the same quotient of 64 divided by 8. So you've got 64 divided by 8. What's a quotient? Ah, the quotient's the answer. So we're going to put over here that the quotient is the answer. I remember this like DQ, Dairy Queen, division quotients. Or the queen, Q, sits on the top of her throne, maybe. Now, don't think about division. Think, what times 8 is 64? Because division and multiplication are a family. Right, it's 8. 8 times 8 is 64. So 64 divided by 8 is 8. So I want someone with the same quotient. 32 divided by 4. So really I'm thinking, what times 4 is 32? 8. Is that what I want? No, remember we want the one that is not the same quotient. That is the same. 40 divided by 5. So really I can think backwards. What times 5 is 40? Yep, 8. That is the same. I want not the same. What are we thinking here? Yeah, what times 7 is 56? And it's going to be 8. So your answer is going to be right here, because it's going to be 9 times 6. But bring back the fact family. And then once you find it, why don't y'all go ahead and come off to the side, if you're watching the videos, and add in your fact family to reinforce this skill. 54 divided by 6 is 9. 54 divided by 9 is 6. Who goes with divide? Multiply. 6 times 9 is 54. 9 times 6, 54, your fact families. All right, girls, read us the next set. All right, y'all, what do we need to summarize? We want 2 cards not belonging stack. Well, let's look at these stacks. It says that rectangles and what's that word? Parallelograms would not belong here. Well, what's a rectangle? Are any of these a rectangle? Oh, the first one. How do you know that this is a rectangle? No, I want some like mathematical reasons. What do we know about rectangles? They have 4 right angles. That's one of their attributes. What else do we know about it? Oh, okay, it's a quadrilateral. 1, 2, 3, 4. What else do we know? Y'all don't remember? Well, what do we know a parallelogram is? Parallelogram with those two L's. Parallelograms are quadrilaterals with two sets, parallel, parallel. That's a rectangle. It's also a parallelogram. So these would belong. Circles and triangles. Would circles belong up here? Looks like it. Would a triangle? Yeah, so I bet that's good. What about a rhombus and a parallelogram? Oh, I'm dumb. I'm looking at this the wrong way. Y'all, I'm sorry. I'm tired. Don't do this with the kids. Which two of these do not belong? Which do not belong in this category? How do y'all know it's the circle and the triangle? Yeah, because this is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. If you have 4 sides, you are a quadrilateral. These two are not quadrilaterals. And I would definitely write that. That'll help them with their assignment. All right. Read the question to yourselves. What should we summarize out loud? We do this. We want a 3-dimensional figure, circular base. Where's the base? The bottom. Okay, cones. Like an ice cream cone. Do they have a circular base? Yes. Do pyramids have circular bases? No, pyramids have triangular faces, right? And their bases are often squares or something, but no. Sphere and cube. Well, spheres are the ball, right? They're circular. What about cubes? Do they have circular bases? Not at all. Cylinder looks like what? Can of green beans. Do they have a circular base? Yes. Does a cone? All right, so these are your answer right here. All right, so you can see how we're just going over lots of skills. All right, let's look at this T-chart. And remember, it's a T-chart because it makes a capital T. It's a table with votes. So we're going to use these symbols to compare Terrell Gist votes to the other 3. All right, so what's Terrell's number? 25 what? Yeah, 25,357. And we're going to use this number compared to the other. So let's go ahead and write it 3 times. All right, Leon's number. I want y'all to read me the number. It's what? And get them to read it out loud so they're saying numbers correctly. 25,375. Don't let them say and. All right, so let's compare. If y'all look, 25 is equal to 25, right? 300 is equal to 300. But right here, 5 is what compared to 7? 50 is less than 70. 1 dot is less than 2 dots. All right, read me the next number up there. 30,037. Well, 25,000 compared to 30. 25,000 is, that's right, less. 1 dot is less than 2. What's y'all's last number? 25,099. 25 is equal to 25. 300 is what compared to no 100? 300 is more. That's right. 2 dots are more than 1 dot. So there you're using your rounding and comparing, not rounding, but comparing. All right, class, read about the 4 families. All right, so then look at the question. Y'all read me the question and give them time to read the question, then go, what are we looking for? We're looking for the fraction of tomatoes each family receives. Well, they want a fraction. What do we know fractions have? Fractions have numerators and denominators. All right, so when we answer this, it better have 2 parts. How many families are there? 4. Yep, there's family 1, family 2, family 3, and family 4. And they picked 2, 4, 6, 8 tomatoes, right? So let's split up 8. 1, you get 1, you get 1, you get 1, you get 1. How many tomatoes is that? 4. Give him another. 5, 6, 7, 8. Each family is receiving what? 2 tomatoes. Good. 2 out of D divided into, 8. Each family is getting 2 8s. All right, girls, read us about the Pet Palace. The girls read the question. All right, boys, what should I summarize? I want the sentence representing fraction puppies adopted. Well, which puppies were adopted? Oh, she adopted a spotted one and 2 black. So how many of these puppies were adopted? 3 out of how many? 4. So we need 3/4. See that equals? Equals. We want to equal 3/4. Do those equal 3/4? Nope. There it is. Because 1 out of 4, 1 out of 4, 1 out of 4 makes 3/4 together. All right, over here. We're looking at polygons. Bring back what you know. What are polygons? They're plane figures. What does that mean? Flat, straight-edged, closed. Good. I want you all to read the question to yourself. All right, what are we looking for? True statement. That's right. So they're all talking about the perimeter. Let's circle the root word, that rim. Rimeter. Where's it at? It's all the way around. How do you find it? Add the sides together, write the unit down. Or I could go around the rimeter. Let's go ahead and just find, before I read these, let's just find the rimeter. So A, see where I'm going to start? I'm going to go over 1, and then we're going to go up. So y'all go ahead and put a mark, and let's count together. So that's 1, go up. 2, 3, over, 4, 5, 6, go down. 7, 8, 9, 10, over, 11, 12, up, 13, 14. So this guy has a perimeter of 14 units. Can't say centimeters because we don't know. All right, let's find the rimeter of B. Let's go down right here, starting here. Or let's go over and then down. 1, y'all ready to go down? 2, 3, y'all should be doing this. 4, 5, 6, 7, 8, 9 is up, over, 10, up, 11, 12, 13, 14. B has a perimeter of 14 units. So what can we say is true? Yeah, H. They have the same amount. And I don't have to do any of the other math just by seeing that they were all about perimeter. All right, on this one, y'all, we want a dot plot to match. So what do you think 75s, 80s, 85s, and 90s represent? Okay, those are the scores. Frequency. If I ask you how frequently you go to the bathroom or how frequently do you do your homework, what am I asking? How often? So write that down. Let's write that down. Frequency. I'll say frequency. All right, frequency is how often. And I'd get up and go look at this point to make sure they're writing it down. So how frequently was a 75 made? Once. So let's look down here. Do all 75s have one frequency? Yes. How frequently was an 80 scored? 4. Well, let's look at the dot plot. Does this one have 4? Yes. Does this one? Nope. 4, yep. 4, nope. All right, how frequently were 85s made? 3 times. 3. Does that have 3? No, we already marked it out. Does that have 3? All right, 90s, how frequently? 4 times. Nope. So it's got to be C. Yep, 1, 2, 3, 4. So it's just a matter of matching. All right, so it seems like a lot, but, I mean, this is just quick going through. All right, we're going to look at the bar graph. Before we answer questions on a bar graph, you better check out the graph like a book. What is your title of this big graph? Favorite cafeteria food. And 1 is for Mr. Wynn's class, and 1 is for Mrs. Jade's class. What are the bottom representing? Yep, those are the foods. And what are the numbers? Students. Okay, we need to figure out what it's jumping by. Let's count by 1. 0. 1, is that 2? Let's try 2. 0. 2, 4, keep going. 6, 8. Let's fill that in. 2, 4, 6, 8, 10. All right, let's label. Pizza was 10. Nuggets. Nuggets is going right here between 4 and 6. 5. Nachos is right up on. Good. 8. Pizza. Pizza is like the nuggets. It's between 4 and 6, so that's 5. Nuggets is 8. And then this one will be 9 if you went over. Or you could be smart and just copy 2, 4, 6, 8, 10. That's probably what I would have done. All right, now that we've labeled it, this is showing our work. Let's read. Boys, read us the next one. All right, if I wanted 4 important words, just 4. Do y'all know what 4 words I want? How many fewer than? How many fewer chose pizza in her class than his? Dun, dun, dun. Versus, how many more students choose pizza in Jade's class than Wine's? This is like that 50-yard line on a football field. If you've got one team here and one team here, it is not combining, it is saying what's different. And the answer to subtraction, that's called a difference. And I would make them write all that. So, Mrs. Jade's class, how many chose pizza in Mr. Wynn's? 10. How about Mrs. Jade's? 5. How much more is 10 than 5? 5. How'd y'all know that so quickly? Yeah, because you know the fact family, 5 plus 5 is 10. All right? I want y'all to read the next one, boys. All right? We're looking for total students, 2 classes, not voting pizza. So we want the total number of students in both classes that did not vote pizza. Well, if you did not vote pizza, what did you vote? Nuggets and nachos. And for both classes, we don't want pizza. Well, here's what I don't know. What's 8 plus 9? 17. What's 8 plus 5? 13. What's 7 and 3? 10. And then that leaves you 3 ones. So the answer is H, 30. All right, look down here at a pictograph. When we have a pictograph, you better read it like a book before you answer questions. What is this about? Ice cream sales. All right, should I just start counting? No, why not? Oh yeah, you better look at the key. Each cone represents what? 8. So we're counting by 8s. So this is 1, 2, 3, 4. This is 4 groups of 8. What's 4 8s? 32. What is this? It's half, right? So look, if I have a circle and the whole circle is 8 and I chop it in half, hi-ya! What plus what is 8? Yeah, 4 plus 4. So it's 32 plus 4, which is? 36. All right, here's what I know. 1, 2, 3, 4. 4 groups, all of these are 32, right? You could do that. So that's 32, and another 4 is 32. And then you have a group of 8. That's 10, 12, 6, 7. So here's 72. Or you could just go 1, 2, 3, 4, 5, 6. 6 times 8 is 48, plus the half, which is 52 right here. And then 1, 2, 3, 4, 5, 6. 6 times 8 is 48. All right, let's look. We want to know how many more chocolate than choco chip. How many more are this than that? Dun, dun, dun. We want to know the difference between chocolate, 72, and choco chip, 48. How much more is 72 compared to 48? Is 2 enough to pull 8 out of? No, so we take away one of these 10s and regroup it into 10 singles. Plus 2 makes 12 minus 8. 8, 9, 10, 11, 12. And 6 minus 4 is 2. All right. What do we want? We want cones sold. Cones sold when? In August. He wants to double the sale in August. Well, when is this? How do you know it's July? Ah, it says this is July. He wants to double his sales. Well, how do we know how many ice cream cones he sold? Oh, you better add up all of the ones together, and all of these would be how many he sold in July. So 72, 52, 48, and 36. You'd be smart to look for like this. 2 plus 2 is 4. 4 plus 6 is 10 plus 8, 18. 1 and 4 makes 5. So 5 plus 5, that's a 10. 7 plus 3 is 10. That's 20. If you double it, double is how many times? Double is 2 times, twice. So that's 16. And there's y'all's answer. So this is tomorrow's notes. And I had started doing the practice, or the assignment. And here's the assignment. So I figure it'll probably take an hour to do this. Don't even worry about multiplication tomorrow, just an hour of that. I definitely would have them get their multiplication tables out or their flip cards out because they're going to need it. And then this is their assignment. And it looks a lot the same. You've got your unit fractions, you've got product, quotient, perimeter. It looks like a lot, but it's big amounts. I like this. They have to, you might read them to the directions of this and do like 1 or 2 together. The even numbers go in the apples. So all of these up here would be even, and all of these on the ground would be odd. So I might read the directions of that section. But for the rest, they can look at their notes and just use what they're doing.